Okay, we're solving the following questions on the sum to infinity. So question 1, part 2, find the sum to infinity of the following geometric series. So you put down your formula for the sum to infinity on page 22 of the log tables. You need A and you need R. So A is 3/7, your first term. Common ratio. Term 2 divided by term 1. So 1/7 divided by 3/7 will give you back a third. So common ratio R is a third. Sub into your S of infinity formula. You end up with fractions divided by fractions, and you should get out 9/14 as your S of infinity value. Part 5, A is 2/3. Get your common ratio, one term divided by its previous term. So 1/12 divided by 2/3 gives you 1/8. So R is 1/8. Sub it into your S of infinity formula, tidy it up, and you'll get 16/21 as your evaluated answer. Question 2, find the sum to infinity of each of these. Again, get your common ratio and get your value of A. A in the first one is 8/5. Your common ratio is -1/2. So again, term 2 divided by term 1 will give you -1/2. Or you could check term 3 divided by term 2, you'll get -1/2. Subbing it into your S of infinity formula, just remember a minus multiplied by a minus becomes a plus. So 1 plus 1/2 gives you 3/2. All right, fractions divided by fractions, leave the first fraction alone, change your sign to multiply, flip the second fraction, and you can go on to your calculator. 16/15 is your S of infinity formula there. Part 3, A is your first term, 7. Common ratio, term 2 divided by term 1, and you should get back -1/3. Sub it into your S of infinity formula, tidy it up, you should get back 21/4 as your sum to infinity of that series. Question 3. Evaluate each of the following. So this is sigma notation, which again just means the sum of. So it's the sum of this expression from n equaling 1 up to infinity. So that's an S of infinity sum in that instance. You can write out the first couple of terms. Okay, so starting at n equal to 1, sub it into that. The first term will work out to be a 1. Sub in n equal to 2 into that. Second term will be a half. If you subbed in n equal to 3, you'll tidy up and it'll be a quarter. You could sub in n equal to 4 and you'll get the next one. Okay, you only need the first 3 terms. So get your common ratio. Term 2 divided by term 1, a half divided by 1 is a half. Or you could check a quarter divided by a half will give you a half as well. So my common ratio is a half. The first term was 1. Sub it into your S of infinity formula and it should all equal 2. Part 3, again, it is the sum of this expression from n equaling 1 up to infinity. So again, it's a sum of infinity formula. Just write out the first couple of terms. So start at n equal to 1, then n equal to 2, then n equal to 3. And that's enough. You don't need to do any more than that. Okay, your common ratio then, term 3 divided by term 2 will give you -1/2. Or you could say term 4 divided by term 3 gives you -1/2. So that's your common ratio. Or just remember a minus by a minus will become a plus. So 1 plus a half is 3/2. 1 divided by 3/2 is the same as 1 multiplied by 2/3, 2/3. Question 4, the sum to infinity of a geometric series is twice the first term. Find the common ratio R. Okay, so it's a geometric series. They were already after telling me that the sum to infinity is twice the first term. The first term in a geometric series is A. So therefore twice the first term would be 2A. And they were after saying that the sum to infinity equals 2A. So I'll put that down. There's my sum to infinity formula. That should equal 2 times the first term, so 2 times A. So I now have an equation. Okay. Then, don't like fractions, so the first thing I would do is I would get rid of the fractions by multiplying both sides by the common denominator. Or alternatively, given that both sides have an A on it, you could divide across by A first. Doesn't really make a difference which way you go. I'd probably get rid of the fractions first. Okay, by multiplying both sides by the common denominator, then I would tidy that up. Okay, 1 minus R divides into 1 minus R, so fraction's gone. Okay, then you'd be left with this. You could bring your A's to one side if you want, or you could multiply out the brackets. Your instinct would probably say brackets mean multiply, so you could multiply that out. It just means that when you do that, you'll actually have 3 terms that all have A's in it. So it probably would be easier if you just divided both sides by A at this stage. All right, because then you'd say A into A goes once, and A into A here goes once as well. So then you'd be left with this. 1 is equal to 2 times that bracket. You can then multiply that out. Then you could bring your r's to one side. I brought them to the left. 2 take away 1 is 1, and then to get r on its own, divide across by 2. And you'll get r on its own is now equal to a half. So I've now found the common ratio for r. So you can do it a couple of different ways. It's just working with an algebraic equation. It doesn't really matter what way you want to do it. Question 6, the second term of a geometric series is a half. So I'll put down term 2 equals a half, and remember for a geometric series, first term is a, the second term would be ar, the third term would be ar squared, and so on and so forth. So term 2 equals ar, which they said was a half, so I let that equal a half, and I now have an equation. They said the sum to infinity, s of infinity, is equal to 4. So I'll make note of that as well. Find the first term, so find a, and find the common ratio for the series. So find a and find r. Okay, so I'll put down the sum to infinity of a geometric series as well, a over 1 minus r, and that should equal 4. So you'll have two equations that have a's and r's in them. So now we just have to solve them. Technically, you're going to be solving them using simultaneous equations. But it's quicker if you just get one of the variables on its own. So I could isolate r, get r on its own, and then sub in for this equation here. Or you could get a on its own and sub into that equation there. But remember, you can never solve an equation with two unknowns. That's why we have to do manipulation, or else we do simultaneous equations. So I'm going to work with this, and I'm going to get a on its own. So I divide across by r to get a on its own. That will then leave me with a is equal to 1/2 divided by r. Leave the top fraction alone, change your sign to multiply, flip that second fraction upside down. R on its own will be the same as r over 1. So then if you flip it upside down, it becomes 1 over r. Top by top, bottom by bottom. A can now be written as 1 all over 2r. So I've now expressed a in terms of r, and I can sub my value for a back into this equation here. So where you have an a, I'm going to replace it with 1 over 2r. Okay. So now we just have to look at this and solve this equation. It's all in terms of r now, so I know it's solvable. I don't like fractions, so I would multiply across by the lowest common multiple, which is 1 minus r. Then simplify above and below. The 1 minus r's divide into each other, so you're left with 1 over 2r equals 4 times that bracket. Brackets mean multiply, so I would multiply that out next. Okay. Again, I don't like fractions, so get rid of the fractions. I'd multiply across by 2r. Simplify above and below. You are then left with the following equation. Now it's starting to look like a quadratic. Bring the 1 over and subtract it, and the whole thing then equals 0. Solve it using the minus b formula. Okay, so I subbed into my minus b formula. A is 8, b is minus 8, and c is 1. I will get out two solutions for r. R is going to equal 2 plus the root of 2 over 4, or else r is going to equal 2 minus the root of 2 over 4. Leave it in third format. If I'm after getting two values for r, then I need to go back and find my values for a. Remember what we said a was. We isolated a, and we were able to write a in terms of r. So a equals 1 over 2r. So now I have to say, well, what about when r is equal to 2 plus root 2 over 4? Sub it in, get out a value for a. Then what about when r is equal to 2 minus root 2 over 4? Sub it in and get another value for a. Okay. So that's my expression for a. If r is 2 plus root 2 over 4 and I sub in instead of r, and calculator will do the work for you, you should eventually get out 2 all over 2 plus root 2. Now, the calculator will automatically rationalize the denominator for you, so it won't give you this answer, it will rationalize it. It'll give you back this answer instead, which is perfectly fine. So that's one value for a, 2 minus root 2. Okay, then what about when r is equal to 2 minus root 2 over 4? So again, I'm going to sub that in instead of r. Again, calculator will do the work for you. If I didn't use my calculator and I did it by hand, this is what I get back, but the calculator will give you the rationalized denominator version, which is 2 plus root 2, all over 1. Okay, so those are my two different values for a. Those are my two different values for r.